Hello everyone, this is VZMoD. Based on the feedback we received from ArcNLET-Py user, today I'm going to give a brief introduction to the profile output generated by the VZMoD module. Here is the VZMoD GUI. As you can see, when you run VZMoD, you need to specify a name for the output text file. This file contains detailed information about Vadose zone processes, and it helps us understand how water and nutrients move and transform in the Vadose zone. So, if you want to examine what exactly happens in the Vadose zone, this file is extremely useful. Okay, this file includes soil water content, correction factor of nitrification and denitrification rates, and the concentration of ammonium, nitrate, and phosphate. Let me open a demo to show. Okay, here is a lecture example, and we enter VZMoD module output, and we can find this is profile information, and you can see the output is organized by OSTDS. This is for OSTDS 0, and this is for OSTDS 1, and you can scroll down to find the other OSTDS. Each block has several columns, and the variables are what I showed here. Okay. And then another question is how we connected OSTDS with this OSTDS number. Okay, each OSTDS has a unique ID called OSTDS ID. For example, let me open my ArcGIS. Okay, these files are the input file of a lecture example, and this file shows the OSTDS location. Let me right-click the file and show attribute table. Okay, we will find there is a column named OSTDS ID here. Okay, this is a key field used to identify different OSTDS. And let me select OSTDS 1 and okay, this one. This is OSTDS 0 and the profile data shown here correspond specifically to this OSTDS. Okay, if you want to explore how different variables change with depth for this OSTDS, you can copy this data into Excel and make some plots. Of course, you can also use code to make the plots. Here I will use Excel as an example, and here are the figures I plotted. The vertical axis is depth below the ground surface, so the top represents the surface, and as you go down, you move deeper. The first figure shows the soil water content profile. This is a steady state profile simulated by VZMoD. You can see the soil water content is relatively low here near the surface, and this is saturation at the water table. The second figure shows the correction factor for nitrification and denitrification rates. In the VZMoD module here, we need to input nitrification rates, that's this parameter, and the denitrification rate, that's this parameter. But we need to know these values are ideal value. The actual value vary with soil water content and temperature. Therefore, this plot tells us how much the rates are modified during calculation. For example, if the ideal rate is 2.9. This is the default value for nitrification rate, and the correction factor, let's suppose, is 0.1. Therefore, the actual rate during calculation is 0.29. We can see that as the depth increases, the correction factor for nitrification first increases, then decreases, while the correction factor for denitrification keeps increasing. I will explain this later. And the third figure shows ammonium and nitrate concentration profile. We know that septic effluent contains mainly ammonium, so ammonium is high at the surface. As nitrification happens, ammonium is converted to nitrate nitrogen, and the nitrate concentration increases at first and later decreases. The decrease is due to denitrification. Okay, let's go back to ArcGIS Pro, and well, if you pick multiple OSTDS here and set spatial varying parameters like KS or theta or water table depth or multiple soil types, then the ammonium and nitrate concentration entering the groundwater will end up different. This is because their soil parameters change how water and soils move through the Vadose zone, which affects how the contaminants travel and transform. Okay. In our model, the relation between soil water content and the correction factor is shown in this figure. For nitrification, the correction factor increases and then decreases as soil water content increases. A simple explanation is that nitrification requires both water and oxygen. So there is an optimal soil water content level where the correction factor is 1. But for denitrification, oxygen is not needed, so the rate increases with soil water content. Okay, if you want to learn more, please feel free to read this VZMoD manual and this reference report. And thank you very much. That's all.